Hey everyone. So for today's lesson, I'm just gonna go over like how to do one from the worksheet yesterday. This is number 8. And then for the assignment, not really graded, but the assignment for today, you're going to complete the front and back side of that worksheet. I'll type out more directions on Google Classroom because I think I will know more based on what we're doing as a school moving forward by the time I post this. But anyways, when you see a graph like this, y equals 1/2 sine of 2 theta, you should always first base it off the parent graph. So our parent graph is y equals sine of theta. And I actually saw a YouTube video. I learned a lot on YouTube about kind of random math stuff during this shutdown, which has been kind of nice. And what I learned was the guy said, just always graph a sine curve like this. So sine starts at 0, it goes up, it comes down, it comes back down, and then it goes up again. I screwed that up though. I'm gonna erase that. So I went, oh geez. So it starts at 0, goes up, it comes down, comes up, and it comes down again. Now notice how I had markers set for like every 2 spots, every 2. This is supposed to be right there, and then every 2. Now when you graph a sine curve, any sine curve, it doesn't matter if you have these changes made in it or not, just start by graphing that sine curve, because then what you can do is you can just change your labels. For example, what I can do is I can say, well, for the parent graph, for the parent sine curve, it goes up 1 and down 1. It takes 2 pi to repeat itself. That means this is pi. That means this is pi over 2. And this is 3 pi over 2. The graph is going to look the same, just the labels that I have are going to change on it. Okay, now when I graph number 8, it's going to be the exact same shape. It's going to start at 0. I'm going to go over 2. I'm going to go over 2 more. I'm going to go over 2 more, and I'm going to end right there. So I start at 0. I go up. I go down. I go down. I go up. Now, what this 1/2 tells me right here, what the 1/2 tells me, is that changes the amplitude. And again, the amplitude is how tall something is. So instead of going up 1 like I did before, that 1/2 makes it only go up 1/2. This makes it go down 1/2. Now, I understand that these two graphs look the exact same, but they're not, because again, I'm changing the scales on these. Now later I'm going to put this red graph on the blue one, but for now it's easy to just kind of throw new labels on the graph, okay? Now, if you remember, this 2 changes the period, and the period just means, hey, how long till this thing repeats itself? Because again, both of these go on forever and ever and ever both ways. This goes up and down and up and down and up and down. But that period tells you, hey, how long until it repeats itself? So it's going to stretch this horizontally. So it's going to stretch or shrink it like an accordion. It's either going to push it together or stretch it out. Okay, so to find our period, we do 2 pi over whatever this number is, 2 pi over 2. Well, 2 pi divided by 2 is just pi. Now, what that tells us is instead of taking, I'm struggling, it's early, 2 pi to repeat itself, now this graph is going to repeat itself in only pi. And now we got to think about this logically. Well, what's this point going to be? It's halfway between 0 and pi. Again, this whole thing takes pi to repeat itself. So halfway between 0 and pi is going to be pi over 2. So this point then is now pi over 4. Think about it. If this one is pi over 4, this is pi over 2, what is this one going to be now? Well, that one is just going to be 3 pi over 4. Okay, now now is kind of the hard part. Now I'm going to put this on the same graph as the parent graph. So what I'm going to do is I'm going to say, okay, well, my red sign, my new one, that one started at 0, and it repeated itself all by pi. Okay, that means at the halfway point at pi over 2, it was back at 0, and that makes sense because look, right at pi over 2, I was back at 0. So right at pi over 2, I'm going to be back at 0. And again, this thing goes up, down, into the negatives, and then back up again. But now we got to be careful because my scale on my first graph was set at 1. Well, now my amplitude changed, and it's going to make it be 1/2. So that means I'm going to go negative 1/2 down as well. So I'm going to start at 0. I'm going to go up half. I'm going to come back down to 0. I'm going to come back down here, and then I'm going to come back up again. So now that I've put these on the same graph in this rectangle I'm about to highlight, both of these are on the same graph. We can see that the 1/2 changed the amplitude. It made my blue graph, that's the parent graph, it made the parent graph shorter. The 2 on the inside, it took my parent graph and it compressed it, it squeezed it in like an accordion. Okay, I hope this helps. If you have questions on the other ones, please feel free to contact me. In the future, please submit all assignments through Google Classroom. Try not to email them. Try not to text me or Snapchat me or whatever. Yeah, I want them all submitted through Google Classroom. It just makes my life a lot easier when I'm going through and organizing them and grading them. Like I said, I'll post more directions on Google Classroom after I post this. All right, hope you all have a good day, and I will talk to you on Monday.